Hi sir, so now I will explain my lab 2. First of all, I will start explaining the half adder circuit first. So, the half adder circuit here. So by referring to the circuit provided in the lab handbook, so the circuit outcome will look something like this. So I have connected the positive side of the power supply to the second line and also the last line of the breadboard, and also the negative side of the power supply to the first line and also the last second line of the power supply. Then the 14 pin of both IC is connected to the positive side of the power supply, and both 7 pin of the IC, which is the ground, is connected to the negative side of the power supply. And then both of the output of the IC is connected to the resistor, and the resistor is connected to the anode of the LED, and the whole circuit is completed by connecting the cathode of the LED to the negative side of the power supply. So this LED over here is the indicator for the sun to indicate whether the output is 1 or 0, and this is the indicator for the carry. So basically both the input of the IC will have the same input A and also input B, and then I've connected directly the input A to the IC 74HC08. Both the IC will have the same input 1A and input 1B. So this half adder circuit will have 4 possible output. First of all, we'll connect both the input A and also input B to the negative side of the power supply here. And when I start the stimulation, both the LED of carry and also sum does not light up, indicate the sum and carry as 0. So sum and carry are 0. And then next, I will connect the input 1B to the positive side of the power supply, while the input 1A remain as negative side of the power supply. And then when I start the stimulation, the LED for the sum lights up while the LED for the carry does not light up. Indicate the sum as 1 and the carry as 0. And the third possibility is by changing the input 1A to the positive and input 1B to the negative. And when I start the stimulation, again we have the same output. The LED for the sum is lighting up while the LED for the carry does not light up, indicate the sum as 1 and the carry as 0. And then the last possibility is both the input are positive, which means it's 1, and when I start the stimulation, the LED for the sum does not light up while the LED for the carry lights up, indicate the sum as 0 and the carry as 1. Since the result of 4 output are the same as the result given in the lab handbook, so I can conclude that this circuit is correct. Then next I will explain about the full adder circuit. So over here, again I've connected the positive side of the power supply to the second line and also the end of the breadboard, and then the negative side of the power supply to the first line and also the last second line of the power supply. And then by referring to the circuit provided in the lab handbook, which is the circuit provided over here, I can get the circuit something look like this. So again, all the the 14 pin of all the 3 IC is connected to the positive side of the power supply, and the 7 pin, which is the ground of the IC, is connected to the negative side of the power supply. And then the input A and also input B is connected to the XOR IC, the IC containing the XOR gates, and then the output of the first XOR gate is connected to the is act as the first input of the second XOR gate, which is the purple line over here, and then the C carry in, the C in over here is the carry in, is the second input of the second XOR gate, is over here, input 2B, and the output of the second XOR gate is the sum. So the wire is over here is connected to the register, and the register is connected to the anode of the LED, and the cathode is connected to the negative side of the power supply. So this one is completed. So this LED is an indicator for the sum. And then next we're moving on to the AND gates, and the first AND gates have the input from the output of the first XOR gates, and the second input is the carry in, which is the the blue wire over here. And then the output of the first AND gate is connected to the first input of the OR gate, which is this purple line over here. And then the second AND gate over here is connecting the input A and input B. This is these two green wire over here, and then their output is connecting to the second input of the the OR gate. Sorry, this one is for OR gate. Then the output of the OR gate is connecting to is the carry out. So to indicate the carry out is 0 or 1, so we have an LED over here. So it's connecting to the output is connecting to the register, and the register is connecting to the anode of the LED, and the cathode of the LED is connecting to the negative side of the power supply, and then this circuit is completed. So this full adder circuit will basically have 8 possible output. So first of all, I will connect all the input A, input B, and also the carry in to the negative side of the power supply as 0, which means this 3 line over here is connected to the negative power supply. So when I start the stimulation, both the LED for sum and also the LED for carry out does not light up, indicate the output as 0. So this one is 0 and this one is 0 too. And then next I will connect the carry in to the positive power supply. And the input A and input B remain as negative. And I start the stimulation. Only the LED of the sum is lighting up, while the LED for the carry out does not light up. So indicate the output of the sum as 1 and the output of carry out as 0. And then next, I'll connect the input 1B to the positive and carry in to negative, while the input 1A remain as negative. So when I start the stimulation, only this LED of the sum is lighting up and the carry out LED does not light up, indicates the sum as 1 and the carry out as 0. Then next I will connect the carry in to the positive and the input 1A and 1B remain the same. And when I start the stimulation, you can see there's the LED of the carry out is lighting up while the sum is not lighting up. So the sum is 0 and the carry out is 1. And then next is connect the input 1A, input A to the positive and the input B and carry in as negative. And when I start the stimulation, only the LED of the sum is lighting up and again the carry out does not light up. Indicate the sum as 1 and the carry out as 0. And then I change the input carry in to the positive and the input A and input B remain the same. And when I start the stimulation, okay, the LED of the carry out lights up, indicate the carry out as 1 and the sum is 0 because the LED of the sum does not light up. And then next is connecting the input A and also input B to 1, which means in the positive side of the power supply, and then the carry in to the negative. And when I start the stimulation, only the carry out is lighting up and the sum does not light up. So the sum is 0 and the carry out is 1. And then lastly, connect all the input to the positive, which means all the input are 1. Then when I start the stimulation, both the sum and also the carry out light this up. So both the output is 1. So as we can see here, the result from obtaining from this experiment and also the result which is provided by the lab handbook are the same. So again, I can conclude that this circuit is correct. So that's all from my explanation about lab 2, and I hope you understand what I'm trying to explain, and have a nice day.